Up next, we have Matt McMonagle from NovoHydrogen, and he's going to talk to us about zero-carbon hydrogen. So let's give Matt a welcome.
Hey, everybody. Hopefully everyone's lubricated now after that intermission. Let's do it. Okay, we're going to talk about zero-carbon hydrogen today, and you're probably like, yeah, Matt, no shit, there's no carbon on this screen, right? Hydrogen is the most abundant element out there, but it's never found on its own. So we're going to get into some of the uses here, and I have a couple busy slides, so bear with me here. But basically, hydrogen is used today mostly in refining and ammonia production, which is the main ingredient in fertilizer. And the reason we're talking about it in this energy and decarbonization-focused event is that the main way it's produced is from what's called steam methane reforming, where you take natural gas and you split off the carbon, and it goes up into the air. So hydrogen production today is actually 3% of global CO2 emissions, so it is a real problem, and therefore it's something, one, we have to fix if we're going to address climate change. But hydrogen, if it's produced in a zero-carbon way, can also help solve other issues, and that's what we're going to get into today. So you see, it's not a huge part, but it's there. So the new way to make hydrogen is what's called electrolysis, where we're using zero-carbon electricity to split water. Water, H2O, no carbon. This is one of those busy slides. You don't have to look at everything, but basically the point here is that hydrogen can do a lot of things, but that doesn't mean it should do all those things. So there are some things that are more applicable than others, and we're going to get into some of those trade-offs and decisions going forward. But basically, there's a lot of room for growth. Again, if we're making clean and zero-carbon hydrogen in industry, energy, and transportation sectors. And so I'm going to get into a couple examples here, but we get into a lot of what I say are false questions on competition. So is hydrogen better, carbon capture better, are biofuels better? The answer is it depends, right? They're all going to play a part. We need every solution that we can have in the toolkit. But today we're going to focus on these three sectors, industry, power, and transportation, and some of the main applications, or what I think are the relevant applications for using that zero-carbon hydrogen. First one here is cement. Cement production is actually 7% of global CO2. About 2/3 of that is from the chemical reaction. We're going to need CCS for that, but 1/3 is from the fuel used, and that's where hydrogen can play a role, replacing coal or natural gas to provide the heat for cement. Similar with steel. Steel is also about 7 or 8% of carbon emissions, and we're surely going to have a lot of cement and in concrete and then steel to build everything for the energy transition, so we need to decarbonize these sectors. Power, this is a combustion turbine. We can replace natural gas with hydrogen. It's not very efficient, so engineers get a little squirrely around this, but you can turn it off and on like a light switch and fill in the gap when the sun isn't shining, the wind isn't blowing. I mentioned ammonia earlier. The chemical formula is NH3, so we have hydrogen in there. We can get nitrogen from the air. So again, this is a big use of hydrogen today. We need food, and this is something we're seeing today with supply chain shocks in Ukraine and Russia, which are big nitrogen and ammonia producers. You can also make what are called e-fuels. So you make hydrogen, and then you get some sort of carbon, whether that's from wastewater, dairies, whatever. Put it together, and you get traditional drop-in fuels like kerosene. Bill, if you're still around, you might like this one. Battery EVs are about 75% efficient, and fuel cell cars are way less. But the issue is that, again, not competition. Fuel cell cars don't have to recharge for 10 hours. The midstream side, busy slide. Conclusion here, it's really fucking expensive to move hydrogen. It doesn't like to be moved. Therefore, we should try to avoid that. So ideally, if we need it someplace, we should make it there. That's what nature does, right? The distributed generation model. Make it on site, avoid the midstream. That's not always going to be possible. Therefore, we will have to have what I call off-site hydrogen production. But again, we want this to be relatively close to where we're using it, and pipelines are the most efficient way to move hydrogen cheaply. We're not going to replace all the gas pipelines out there, but I expect to have dedicated, more strategic hydrogen pipes. Okay, that's basically what I have tonight. So really appreciate the time and happy to answer any and all questions you might have on renewable hydrogen.